We can find the derivative of inverse functions even when we can't find the inverse itself. Let's go back and look at continuity and differentiability of inverse functions. As long as f is continuous on its domain, then f inverse is also continuous on its domain. While f is increasing, then f inverse is increasing. Now remember, increasing means the first derivative is positive. While if f is decreasing on its domain, then the inverse is also decreasing on its domain. So f prime is negative. Finally, if f is differentiable at c, and the derivative does not equal 0 at that point, then the inverse is differentiable at c. Let's look at what the derivative of the inverse is. Now, this gets very confusing with the f inverses. So we're going to let f inverse equal g. So this is now our inverse function. So the derivative of the inverse is equal to 1 over the derivative of the function evaluated at g. Now let's look at the function. F is 1/4 x cubed plus x minus 1. Does it have an inverse? Well, the first thing you need to see is f prime of x is equal to 3/4 x squared plus 1, which is always positive. So yes, it's increasing, so it has an inverse. So what is the value of f inverse when x is 3? Now you need to think about this. We want to know when f of x equals 3. We're looking for the x when f of x is equal to 3. And it turns out that f of 2 is equal to 3. Now how did I find that? I took 1/4 x cubed plus x minus 1, and I set that equal to 3, and then I solved this function. So f of 2 equals 3. That means f inverse of 3 is equal to 2. So the answer to part A is what is the value of f inverse when x equals 3 is literally asking for f inverse of 3 equals 2. Now, what is the value of f inverse prime when x equals 3? Now, you remember f inverse prime is equal to 1 over f prime evaluated at f inverse at 3. So, this is equal to 1 over f prime evaluated at, now f inverse at 3 is equal to 2. So this is 2. So what I need to do next is find f prime and evaluate it at 2. So this is 1 over 3/4 times 2 squared plus 1, which is 1 over 3 plus 1, or 1/4. So the slope is 1/4. Now you see that we're able to show you that dy dx is 1 over dx dy. It's not that they cancel each other out or they're flipping each other, but mathematically this is a true statement.